Hi, I'm Ms Hearn. Let's get started. In this video, we're going to discuss how to construct frequency distributions and relative frequency distributions. This is a topic from statistics. Remember, in statistics, we're analyzing sets of data. A frequency refers to the number of times a particular data value occurs in a given data set. A relative frequency is the fraction or percentage of times that particular data value occurs in the data set. For example, if we had a set of 15 scores on a math quiz and they're all listed out here, the score 19 has a frequency of 3 because it occurs 3 times in the data set. But its relative frequency is talking about the fraction of times that it occurs. Out of the 15 scores, 3 of them were 19s, so 19 has a relative frequency of 3/15. Relative frequencies can be recorded as fractions, decimals, or percentages, so you might also say it has a relative frequency of 20%. Frequency distributions are a convenient way of listing all the data values in a set, especially when the data set has a lot of repeated items. We refer to the distinct data values as X and the frequencies as F. For example, you might be asked to analyze a data set given as a frequency distribution for the fuel efficiency in miles per gallon for 64 different models of cars. These frequency distributions are often given as tables. The tables could be arranged vertically or horizontally. In this case, it's horizontal. A lot of times, it's a challenge to identify what's actually the data value and what's the frequency. In this case, we've been given a clue because it actually says frequency. So that must mean that the miles per gallon are the data values and the other values are the frequencies. But it makes sense because the miles per gallon, it's telling us a description of the vehicle. A vehicle gets, for example, 19 miles per gallon. How many vehicles have that characteristic? 2 of them. Let's use this same set of data and find the relative frequency of models of cars that get 22 miles per gallon. Remember, relative frequency is the fraction of times that particular data value occurs. Remember also, there were 64 car models listed. In fact, if we added up all the frequencies, 2, 5, 3, 6, 6, 7, 8, 8, 4, 7, 6, and 2, you would get 64. Looking for 22 miles per gallon, we see that there are 6 cars that fall into that category. So 6/64ths of the cars are in that category. We can give our answer as a reduced fraction, 3/32, or as a decimal, 0.09375, or as a percentage, moving the decimal place 2 places to the right, that's 9.375%. On your test and in your homework, you'll be told which format to give your answer. Let's look at another example. We're told that 10 students in a math class were polled as to the number of siblings in their individual families, and were asked to construct a frequency distribution and a relative frequency distribution for the responses. Here we've listed the data from the survey, and we've set up 2 tables. The one on the left will be our frequency distribution. The other table is for our relative frequency. Notice that in each of these distributions, the first column is the actual data values in the set, because in our data set we have numbers 1, 2, 3, and 4. So that's all we have to list right here. In the frequency distribution, we need to count how many times each data value occurred. Now it's tempting to go and start counting through the data values and see how many times 1 occurred, which appears to be once, for example. But using that method takes a little bit longer than necessary and also tends to lead to errors. So what I recommend is that you actually do what's called a tally of the data values. By this method, look at the first item in the data set, that's a 3. I'm going to cross it off and I'm going to put a little mark next to 3. Then I'm going to go up here and cross off the 2 that's next to put a little mark next to 2. The next value is a 2 also, so I'm going to put a mark next to 2. The next value is a 1, and then a 3, and then a 4, and then a 3, and then a 3, and then a 4, and then a 2. So then it makes it a little bit easier to count how many of each we have. For 1, we have 1. For 2, we have 3. For 3, we have 4. And for 4, we have 2. Now to find the relative frequency, all we need to do is to divide the frequency that we just found for each data value by n. N always refers to the total number of data values in the set. Now you can actually count the number of data values in the set. We were given in this case If we refer back to the original problem, we were told that there were 10. Or another way of getting the data value in the set is to actually add up the frequencies. By the way, the symbol for adding up the frequencies looks like this, capital Greek letter sigma. So what that refers to is 1 plus 3 plus 4 plus 2. So the total number of data values is 10. That means that the fraction of times that the number 1 occurred in our data set is 1/10. The fraction of times that the 2 occurred is 3/10. The fraction of times that the 3 occurred is 4/10. And the fraction of times that the 4 occurred is 2/10. If you're going to leave your answers as fractions, you should reduce. 4/10 could be reduced to 2/5, and 2/10 could be reduced to 1/5. On the other hand, if you were asked to give your answer as a decimal, we would have 0.1, 0.3, 0.4, and 0.2. Or if you wanted a percentage, that translates to 10%, 30%, 40%, and 20%. Many times, instead of making two separate tables, we combine them into one big table, as you see here. In this table, the first two columns comprise the frequency distribution, and the first and third columns are the relative frequency distribution. I hope you found this video useful. If you did, please remember to like it.